Let's investigate this shape. First, let's start with the number of sides it has. It has 1, 2, 3, 4 sides. So we can classify this shape as a quadrilateral. What else is so interesting about this shape? Let's look. Notice it has a pair of parallel sides going in the same direction. And look, there's another pair of parallel sides going in the same direction. So it has two pairs of parallel sides. Notice too that the opposite sides are equal and parallel. This shape is what we call a parallelogram. And I want you to keep in mind as we do vectors to remember equal vectors have the same length and they go in the same direction. So keep in mind as we go through this video that equal vectors have the same length and they go in the same direction. Now I have a trick question for you. Are equal vectors parallel vectors? That's for you to figure out. We're asked to find the vector A to D or express AD in terms of x. Now, I could start by saying, okay, to go to AD, we need to start at A, travel along AB, and then I'm going to make that turn at B and go towards D. So if I'm going to draw a vector map for AD, it would be A to B and B to D. Seeing that? That's what the yellow line, the yellow trace, the yellow route is telling us. We can get to D from A, which is the vector A to D, by traveling AB and then BD. That's one route. We can take another route, right? We can start at A because remember it's AD we want, So we can start at A, travel along C to C, and then we're going to go up to D now. Good. So AD can be A plus B, or A to B plus B to D, or AD can also be A to C plus C to D. So let's examine the diagram. Alright, so A to B would have been 2x. So this would have been 2x. But we don't know what B to D is. We don't have a measurement for that. So that kind of look like we can't really use it. Let's look at this method. A to C is 3x, good. But C to D, there's no measurement there. So it come like we can't use it. Are we at a roadblock? Alright, let's now apply what we've been learning or what we know about the parallelogram. So remember, in a parallelogram, opposite sides are equal in length. So if this is 3x, then this is also 3x. And remember, parallel lines are parallel sides of the parallelogram. They go in the same direction. So if this one is going up, then this one should also go up. So it's kind of like filling in the blanks. Let's look at this side now. Do you see the parallel side to AB? It's CD. Good. So if A to B was 2x, then the opposite side should be parallel and equal. So this should be 2x as well. And if AB was going up, then CD should also go up. Now that we've filled in the blanks, things look a little easier for us. Alright, so let's see if we can find AD by this route. So A to B was 2x. Let me put in the 2x. And notice I'm traveling with the vector, so it's going to be positive. And now B to D was 3x. So I'm going to put 3x here. And we're traveling with the vector, so it's going to be positive. Now think about it. If you have 2 x's, and then you add 3 more x's to it, how many x's would that be? It would be 5 x's. So A to D, the vector, and let me draw it in and show you what it would look like. So we're starting at A, and we're going towards D. A, and we're going towards D. Great. So the arrow would show that I'm going towards D now. Good. So AD would have been 5x when I travel this route. Just put it in. Good. If I travel the other route, I should get the same thing. Let's prove it. So A to D, I need AC. When I look, AC is 3x, and we're traveling with the vector, so it's going to be positive 3x. Good. Plus CD. And with CD, I'm traveling with the vector, so it's going to be positive, and that's 2x. Again, you have 3 x's and you're adding 2x. You get 2 more x on top of that. So you have in all 5 x's. See? The same 5x that is here and the same 5x that is here. So it's telling us that A to D, that trip, would be 5 x's in all. So when you have a question like this, you want to make sure that you remember the properties of a parallelogram. You want to remember the properties of parallel vectors. You want to remember the properties of equal vectors.